Hello, this is the video solution for the mock exam for core of polynomial functions. First, it says to subtract these two polynomials, and one thing we need to be careful of is that sometimes we don't have the same degrees on each one. So you can see that this one goes 2, 1, and then constant, and this one goes 3, 2 constant, so they don't match up, right? So be careful when you line them up. You're going to put this one on top and this one on the bottom because it's a subtraction. So we're going to put 8m squared, 8m plus 1, and we don't really need to leave any special spaces because they didn't really skip any terms, right? But if you look at this one, they did skip the m term here, right? So we need to leave a space there. So we put the minus 5 here. We put the minus 2m squared here, and the minus 7m cubed here. And then we skip the space here because there's no m term, right? Okay. Now, notice that this is a subtraction. This is the second thing to watch out for. If you have a subtraction, then you want to reverse all the signs in the second line. So I'm going to do that, okay? And then I'm going to add everything together. So I'm going to get 6 here, get 8m here. I don't need to add it to anything because there's nothing there. And then this would be 10m squared, and this would be 7m cubed. And that would be my answer. That's my answer. Here's the next problem. It is a multiplication. And in this case, I have provided the squares here for you to use the lattice multiplication method. You can do it the other way if you want to, the traditional method. That's fine. Okay, so first I just wrote in, I wrote the trinomial here, and I wrote the binomial here. And now I'm going to just multiply every single corresponding term. So 4u squared times u is 4u cubed. 2u times u is 2u squared. Negative 1 times u is negative 1u. 4u squared times negative 3 is negative 12u squared. 2u times negative 3 is negative 6u. Negative 1 times negative 3 is positive 3. Now I'm going to use the lattice to combine like terms quickly. So, for example, this is going to be plus 3. This is going to be minus 7u. This one is going to be minus 10u squared. And this is going to be 4u cubed. And now I'm just going to rewrite it all in a row. 4u cubed minus 10u squared minus 7u plus 3. Okay? Next one. Write out Pascal's triangle to row n equals 5, and hence expand x plus 1 quantity to the fifth. So Pascal's triangle, remember, starts out like this. And then you just start adding up the neighboring numbers. And in no time at all, you've already done the n equals 5 row. How do we know it's the n equals 5 row? Because the second and second to last number are 5. So that's the n equals 5 row. Now it says to expand this binomial to the fifth power. And we know we can do that by writing out the Pascal's triangle coefficients, and then in between we just need to put x to the fifth, x to the fourth, x cubed, x squared, x to the first, and x to the 0. Of course, x to the 0 is just 1. So this is our expansion. That was easy, right? So we have the Pascal's triangle coefficients, 1, 5, 10, 10, 5, 1. And then we have the values with the variable. in descending power. So it's x to the fifth, x to the fourth, x to the third, x squared, x to the first, and then x to the 0, of course, is 1. So you can see that it starts out with x to the fifth, which, comes from that 5 there. Okay? Next problem. Okay, on this problem, we're going to use synthetic substitution or synthetic division to find f of 4, which means we're going to put 4 in for y. Okay, and of course, you can just do that with the calculator, but in this case, we want to see if you can do it with synthetic substitution or synthetic division. First, you're going to take the 4 and you're going to put it here. You just put the same value there. You don't take the negative because this is not synthetic division. You just put in the value y equals 4. And then we're going to write the coefficients, which are these numbers with and without negative signs. Be careful because as in the problems where we combined like terms, we might have degrees being skipped. So here we have 6, 4, and then oops, we're missing the the third degree, and then we have 2, 1, and the constant term. So just be careful that in this polynomial, we're missing the y cubed term. So one thing I like to do is I like to write down the degrees above the spaces where we're going to write them, and then that helps me leave the right space. Okay, so for example here we're skipping the x cubed term, so this one is going to have a space here. So I'm going to put the coefficient 6, negative 22. Make sure you put the negative signs together, and then I'm going to skip that one. Negative 34, 7, and negative 32. Okay. And now I'm going to start the process. And this procedure is the exact same thing for synthetic division. So even if you say, well, I don't want to do synthetic substitution, well, synthetic division is the easiest way to divide polynomials, so you definitely want to learn that. So you've already learned it anyway. 6 times 4 is 24. 24 minus 22 is 2. 2 times 4 is 8. 0 plus 8 is 8. 8 times 4 is 32. 32 minus 34 is negative 2. Negative 2 times 4 is negative 8. Negative 8 plus 7 is minus 1. Minus 1 times 4 is negative 4. And I add those two, and I get negative 36. And that is my answer. How would I express my answer? I would say function f evaluated at y equals 4 is equal to negative 36. So I could write my answer like that. Okay? Or I could just circle it here. All right. Use synthetic division to simplify this expression. Write your answer in the form q of x plus the remainder divided by d of x. d of x is the divisor, and q is the resulting polynomial, which we don't know what it is yet. Okay. R is an integer remainder. All right. So the first part is slightly different because instead of writing the negative 3 here, we would write positive 3. And the reason why is because x takes on the value of 3 when it is a root. So you're supposed to write the root here. You're not supposed to write the value that's being subtracted from negative 3, or subtracted from x. Okay, now we're going to write down the coefficients. Okay, and let's see, are we skipping any degrees here? 6, 5, 4, oops. Yeah, we're skipping 3 and 2 here. So let's see. 6, 5, 4, 3, 2, 1, 0. And so we're skipping the degree 3 and degree 2 coefficients. So I'm going to write the coefficients in now. The coefficients are, the first one is 1, negative 9, 17, and then we're going to skip 2, and then we're going to put 25, and then we're going to put 8. So we bring down 1, multiply by 3, 3 minus 9 is negative 6, negative 6 times 3 is negative 18, negative 18 plus 17 is negative 1, negative 3, negative 9, negative 9. Negative 9 times 3 is negative 27. Negative 27 plus 25 is negative 2. And finally, negative 2 times 3 is negative 6. And when I do 8 minus 6, I finally get the last number, which is 2. This is a remainder this time. Since we're doing synthetic division, the last number is a remainder. So how do you express it in this form? Well, you know how this term was x to the 6th? Well, this term is always going to be 1 less, so it's going to be x to the 5th. So I'm going to have 1x to the 5th minus 6 x to the 4th minus 1 x to the 3rd minus 3 x squared minus 9 x to the 1st and minus 2 constant term plus 2, that's the remainder, divided by x minus 3, which is the original divisor. So this is the remainder term. Okay?